what a day! What a lovely day!
Welcome to Flat Earth Debate. I'm your host Nathan Oakley, and if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and a link in the info box below the video once it's rendered. But most importantly, if you would like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show. Sharing the show increases the live audience, of course, but this in turn increases the chances of a more diverse panel, so please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now, we are joined by Charles, Alan, I don't know who that is because they've got their screen share up, Ranty Flat Earth, Sleeping Warrior, The Plain Truth, The Boss, and Arwin. Good to have you.
Yo!
Hello.
Hello, hello, hello.
Hello, everybody.
So where were we? What are we doing?
We were grilling the boss over his belief that everything looms over the bulge, making it appear like a perfectly flat plane. And in the meanwhile, in the background, we were discussing basically that, yeah, things do distort somewhat. Mirages can basically displace part of an image, but it does never displace the entire visible image uniformly, and especially not around corners.
But yeah, that's the point. Even if we accept that light bends to the rate that refraction is claimed, you've still got to show that it's bending around a bulge. You can't say that, well, because it's refraction explains it, therefore it's right. Even if we accept 7.6R, you've still got to show that there's a bulge for it to bend light round.
Well,
right. He showed us.
That's
he
not
showed us on
this
paper.
topic.
Oh, showing it on paper.
Okay.
That makes
You
it
just
okay.
have to imagine it. It's an
Yeah,
orthographic
fine,
view
whatever.
of
So-
a ball.
So if we go with the on-paper explanation, right? If we start with 2 ice creams and we minus 5 ice creams, we end up with minus 3 ice creams, yeah? But in real world, you can't have minus 3 ice creams. You can only have 0. So does it make it right because it's done on paper, or does it mean that maths doesn't necessarily apply to the real world?
So if I can jump in here, the thing that is interesting to me about the Flat Earth Debate is that there's so much time spent on looking at the horizon when that is one of the worst places to look.
Yeah, only when you lose.
evidence.
So
Because there's no curve.
But we need to understand it. That's the thing. And
hang on. The horizon's only bad when you're losing. When you win in the argument, the horizon's fantastic.
Well, there are certain things you can see when you look at the horizon, but because of refraction, which, you know, like Ranty was just showing with that ship and the letters in the side of that ship.
what, you think that's refraction?
Of course, it's refraction.
What
type of refraction?
I mean, when you
the
Hold on.
compression.
There's many types
Well,
of refraction.
compression.
Sorry,
But-
hold on,
but
Charles. What type of refraction? Does it have a title?
I'm not familiar with all the names of refraction. If you want to call it compression,
Would it be? Let me just guess. Would it be standard atmospheric refraction at the rate of 7.6R by any
no,
chance?
I'm not going to say that. No, not for that ship. No.
Okay, Nathan, can you present my screen for just a moment?
Why wouldn't you assert that? Isn't that part of the spherical model that you adhere to, Charles? This is 7.6 of the radius of Earth refraction called standard atmospheric
7.6 is
refraction. So what refraction are you referring to then, Charles, that can bring things back from behind bulges? What refraction do you mean?
Yeah, if there's
That's a
compression.
loaded question because I never said anything about bringing anything back. I just talked about the distortion in that image.
Nathan, can you
That is
present me?
compression, but at the same time, you also have to imagine
You're up, Ranty.
that it is all refracting around that curve
Okay, well,
at the same time.
can you give me just 1 minute to just show you what I've been working on, and then we can talk about it in a bit of greater depth in the moment. But essentially, I've cropped out the top part of this boat down to this orange part, right? It's been cropped out from this top image. You can see it's exactly the same, right? I've just cropped it out, and now what I'm going to do is I'm going to put it over the boat from the higher observation, right? Just to give you an idea, I'm going to put this cursor to the side of this part of the boat here. And when I move it across, look what happens, right? Because in my opinion, this is identical, right?
Can you make it slightly opaque so
Hang
we
on,
can see
no.
both of the images at once?
Just a minute, you can see this, surely. Surely you can see this, right? This is the same. There's no compression going on. There's no angular size. Well, there's a slight angular size change, but that's just due to the lower elevation. But it's the same proportionally to everything, height-wise, down to the orange. So the orange part here, right, is directly above the orange part there. So the height is the same, right? And then if we look at the top of this here, where I put the cursor, it's exactly the same again when I move it across out of the way.
Oh, Randy,
right. So what?
Can you move the sliding image over it and then blank it out?
I could only really do that if I had an editing software, which I don't actually have right now.
You could just
actually you can. I actually use.
You can just change the layer priority.
Oh right, can you? Right, okay.
I think so.
Let me try that then. Right.
That's the history. That you have to go in the layer box.
Hang on, edit, paste into new layer.
Yeah, exactly.
Yeah.
And then you can make the layer invisible.
How do I do that?
You click the down arrow under the layers tab in the top right corner. Top right corner.
Top right, yeah. Top right.
Yeah.
Over here.
Yeah. A little down.
No, the box
see the
says
little box
layers.
that says layers.
Yeah.
Click the down arrow. It's on the bottom of the box.
That.
Yeah.
Yeah.
That should move it down.
Then it's invisible, so you can move it on the right position and then.
All right. Well, I don't know where it is.
Invisible first.
We'll see the box. See the highlighted box. That's the image. So now you just need to move it back up to the first layer.
With the arrow upwards.
Oh right, sorry.
Yeah.
Yeah, or that one downwards. Yeah.
Right. Okay. Got you.
It's times like these you really wish the show wasn't live. You know what I mean?
Yeah.
Because it's like, I'll make it invisible, right? Okay, now move it. Oh, I can't see it.
Move it slightly upwards. It's almost in the... Oh, now you got the wrong layer.
Oh, it's becoming a comedy of errors now.
Never mind. I'm not bothered. I'm not bothered about this.
His point's valid. It's not compressed in the top half, other than the angle of instant changing. That's it. So
yeah.
You're moving the wrong thing again.
Oh my goodness.
Yeah.
Right. Anyway, the point is that the top part of the boat is proportionately the same as the bottom part of the boat, right? There's no difference in that. But the bottom part of the boat, where the wordings are, is seriously compressed. The height of that S is a fraction of the height of the S underneath. So this isn't refraction, this is compression. To argue the point that it's refraction is, you're doing yourself a disservice, as well as everybody else that's listening right now, because you can clearly see the orange band that runs underneath the wordings. You can clearly see this orange band that runs underneath it. So you know you're seeing down to the floor. You know you're seeing this. So argue that it's not being compressed, you're doing yourself a disservice. The top part of the boat isn't being hampered. That's the same, right? It's the same. But the bottom part, when it hits that refraction area, the dirty air, it compresses it. And to say that that's not compressed and it's refraction, that's wrong. That's really wrong.
Can I clarify something?
Yeah.
Okay, so when you asked me if I thought that was refraction, I said yes. I did. I was not talking about standard refraction. I was talking about the general term, the generic term refraction, which means light bending when it meets different mediums of different densities.
That's fair enough.
Okay, so you are absolutely correct. 100% of the stuff you said was correct. When you say compression is a form of refraction. So are all the various mirages.
What form of refraction?
So, hold on, Anthony. I wanted to get this in at the end of Ranty's bit. So we're back to the original question then, Charles. And as you've got the mic, I may as well ask you. So where's that bulge in the near foreground?
There doesn't appear to be a bulge in this image.
Oh,
that's a bit of a problem.
No, it's only a problem if you make it a problem.
Well, it's only a problem if you think you live on a ball and the ball model dictates that there's a bulge in the way, obscuring your view of the boat. And there isn't one. The boss couldn't concede it. Fortunately, you have. There is no bulge here.
Not in this image. I don't see a bulge in this image.
Yeah, we never see a bulge ever. We never see any curvature ever. Ever do we see any x-axis curvature, which would be the thing that we would need to see in these wide frames that we get in order for there to be a bulge between us and the target. But we never see either. We never see a bulge, we never see a curve.
Don't say never, because there are points where you can see it.
Well, Charles, could I just ask you one other question? Using this logic, right, that the top part of the boat isn't changing, but the bottom is seriously compressed. If we looked on the wind turbines here, and we've got 2 turbines, yeah? And then we're looking at the turbine at the distance. So essentially we're looking at the boat, and the bottom part of the boat or the bottom part of the turbine is being compressed just like the boat. Yeah. Would you agree that this is what you would see over a distance? So if we apply the same logic, that then when the top part of the turbine isn't being affected and isn't in that refraction dirty air zone, right? And it's spinning around, it would look as if the turbines are touching the top of the water.
No. You're correct about the post. If I could clarify, that you're correct about the post, because the post is the same width all the way down. So if that was vertically compressed, it would look the same either way. So I'm gonna give you that point. Okay.
So there it is. It's compressed.
But the part about the turbine blades going in a circle, they're still going in a perfect circle. The circle is not squashed at the bottom.
No, because that's the same as the boat.
But if you see a circle of blades and the blades are literally going below the horizon or below whatever line you want to call that,
they get stretched. They get stretched and bent before they actually hit the water.
Well, I mean, maybe it's another video that you've seen that I haven't seen, but the one that I saw, you could actually trace a circle around the blade, and the circle intersects the line between the sky and the water.
Oh, really? Can you show that?
I've filmed the wind turbines probably 500 times, and I've never ever seen them go around in a perfect circle. I always see them bend and stretch when they get towards the horizon line.
Yeah, so have I.
Every single time.
Randy has shown many different wind turbine videos, and indeed, as he says, when it's far away enough and there is like an obstruction in the way because of the slant, waves getting in the way basically, then indeed, if there is distortion, also the blades, when they hit the bottom part of their rotation cycle, they also distort.
So yeah, when they come into contact into that sort of area where this compression is taking place on the actual stem of the turbine, yeah. So we're agreeing that the turbine stem would get reduced in size due to compression, same as the boat. That would make it so that the hub and the blades would become closer to the actual water. And then as the blades turn around, they bend and warp, and it looks like the cup in the water. And we've had a lot of people saying, "Oh, look at the curvature of the Earth." But I think this image is a very good representation of what we're actually seeing with the turbines.
So again, I'm going to concede your point about the shaft of the what's holding up the turbine, because it's vertical and with the same width. But there are many cases, such as like the CN Tower in Toronto, where it's at an angle where the base gets bigger as you get lower. And there are photographs where there's no distortion right at the horizon. You don't see that the lines changing angles.
Right, but the problem with this, Charles, the problem with this is that you're bringing in another variable that isn't this variable. And it might have other variables that affect the reason why you're seeing it that way. So in my opinion, this is a red herring, because you're simply addressing something else that we would have to address on its own basis. So let's just deal with what Ranty has and not worry about, well, I saw this one time and that might be what, no, let's, I mean, all of this.
I can address it very quickly. This is about compression. This is about something actually being visually warped into another shape. The CN Tower still is very far away and has obstruction of things in the foreground that get below the bottom part of it, as well happens always. Always happens, especially with very, very far away objects. Things in the foreground, which are perspective-wise a lot optically larger than things way in the background, they obstruct it partially.
I think we need to also go back to the point that Charles conceded, where he says I don't see the bulge, but it's there. I mean, he didn't say it's there, but he said I don't see the bulge.
Sorry, I'm back.
Okay.
So the problem is, if Charles conceded and said, yeah, I don't see a bulge, we're still back to the same point. Why not? Where is it?
Can I address that?
I'm sorry?
Okay. All right. Can I answer that? Oops.
Yes.
Right.
Go
That's
ahead.
what I want. That's why I brought it back up.
Okay. So it all depends on distance. So for example, if that ship is in a reasonable distance, like maybe it's more than 3 miles away.
7 miles.
All right. So it's 7 miles away. So if you want to look at the curvature of the Earth with no atmosphere, then yes, you would see a bulge. You would see some obstruction going on. But now that we have an atmosphere, there are very interesting effects, which Ranty has shown in that video.
No, he hasn't. Got to interrupt you there, Charles. I made you clarify what type of refraction we saw in that image, and it absolutely was not standard atmospheric refraction, which is what you're now describing, is it not?
Yep, but no one...
But you've just changed the definition of what type of refraction we see in that image. We do not see standard atmospheric refraction in that image. We made that very clear, Charles. Let's not lie.
So
I think that Charles is going to declare.
Let's phrase it as a
there's
question,
both
Charles. Are you now asserting that we do have?
At the same time.
Arwin,
Nathan,
are you now asserting that we do have standard atmospheric refraction?
Well, what I'm saying is there is refraction.
We've established that. We know what type of refraction we've got. We've detailed it. We made it very clear when I asked you my point and made it very clear. It's not the standard atmospheric refraction, which you are now saying it is.
Standard refraction is not a standard refraction.
Shut up, the boss. Nobody's talking to you. Shut up. Shut up, the boss.
Nathan, you're the only person who's mentioned standard refraction. I never called it that.
You just said we have an atmospheric layer, and if you were to remove the atmosphere, presumably from your ball Earth you believe you live on, we would have a new atmosphere when you insert it, which presumably would be the standard atmospheric refraction you are now detailing. Correct, Charles?
No, absolutely.
So it's not refraction to do with the ball, then? You're just saying it's the same. We've already made this point. We've already established exactly what kind of refraction it is already. So let's move on.
Well, okay, but Nathan, what
Charles,
you're trying to do is you're trying to force something into a little box.
If the atmosphere would be taken out, you would see a bulge in front of it.
Absolutely.
So you're basically inserting that because of the atmosphere, it
been
is all looming around the bulge, which is the effect that standard refraction is supposed to do.
Right, exactly my point, Arwin. Thank you for clarifying it and backing me up. I really appreciate it. So he's done the old switcheroo. We've talked about one kind of refraction, and now we're talking about his special ball refraction, aren't we, Charles?
No.
Yeah. We are now talking about 7/6 refraction, standard atmospheric refraction.
I never mentioned that fraction.
Yeah, I'm telling you what you are doing, because I'm not stupid and I see what you are doing. You have told us that we have one type of refraction and conceded there is no bulge. Now you are saying that that is only the case if we remove all atmosphere. You're trying to be clever, but you are dumb, Charles, and we see right through what you are doing.
You can just leave out the names and not mention the trigger words.
Yeah, let's just not call it.
But it's still the same effect you're trying to describe.
Sneaky little sod. Well, you won't get that past us here, Charles, you sneaky little sod.
All right. Well, the thing is, my understanding about this show, this debate show, is that you want a diverse panel. You want to hear from people. But it appears as though you don't actually want to hear what I have to say.
How dare you? I heard what you did, and I'll assert it again. What you did was establish a precedent with Ranty of what type of refraction was in the picture. You also conceded we see no bulge. Then you did a very clever thing by saying that's only the case if there's no atmosphere. Is there no atmosphere in Ranty's picture, you retard, or are you trying to be clever with us?
Charles, can you see my screen?
Charles, hold on, Ranty.
Yes,
is there no picture in... Is there no atmosphere in Ranty's picture? Giving you plenty of time to answer, Charles. All your opinions are welcome.
What purpose is served by asking a question that you know the answer to?
Yeah, I know you're a deceitful little shit. I realise that, Charles. You've told us that one picture, when looking at it and identifying the type of refraction, is not standard atmospheric refraction. Then you claim that it's only the case that we would see a bulge if we removed all the atmosphere. Well, you haven't removed the atmosphere from Ranty's picture now, have you?
So, Nathan,
this looming?
We've
Is this
caught
about
you,
looming?
Charles. No,
That
so
is a
no
stupid
asking me
question.
questions.
If the
Just
two
admit
of
your
us
little
were
cheap
actually
trick.
having a conversation, you would
Admit
not
your
be
cheap
speaking like
trick.
this.
Nathan, I'd like to move past this.
I wouldn't. I want Charles to admit his cheap trick. He's tried to switch what type of refraction we're talking about, haven't you,
I
Charles?
never said the type.
Yeah, we know what type of refraction when you remove the atmosphere from a ball that you are trying to hypothesize about. We know what type of refraction. You don't need to say it. We know.
No, I don't think you do.
Yeah, I think I do. I think I know how deceitful you are. You established the precedent when you said it was not atmospheric refraction. That's why you're getting shouted at.
What? I said
I established that it was not atmospheric refraction that we were dealing with when you conceded that we do not see any bulge, and we do not. That was based on a picture. Now you're taking us to Fantasyland and removing atmospheres. We don't need to go to Fantasyland. We've got a bloody picture.
so. There are various types of refractions. However, what if you just don't name the refraction? Just don't even give it a name. Just say refraction exists. Right?
Yes, so
Then-
what is the
then there
type of
wouldn't be all this
refraction
upset
that
about
is
which type
caused
it
by
is.
an atmosphere that bends visual
Charles.
things around
Charles.
this bulge?
Charles, if
Yes.
it was if it was refraction of some form, doesn't matter what the form is, and it doesn't matter what you call it.
Yes.
Do you agree that the refraction is still subject to the bulge or the curve being there, and you have to show that whatever
So-
refraction it is?
Yeah, the thing is, the refraction doesn't really depend on what the shape of the Earth is underneath it.
I think
If
it
the
does.
Earth
It's
were
part
flat,
of the
you'd
reality.
have refraction.
Yeah, it
If
does.
the Earth
Yeah,
is a
it
globe,
does.
you'd
Yeah,
have
it does. We're
refraction.
on the Earth. It does absolutely depend on the Earth that we're on. Atmosphere is part of the Earth that
If
we
the
live
Earth
in.
was still flat, you would still have some form of atmospheric refraction. It would just look
Yes.
different.
Yeah,
from what
like
we observe.
compression, like we see in this picture.
Yeah, but whatever the refraction.
Any chance we can get a couple more guests from the audience just to join so we don't have to interrupt Charles having his ass handed to him, because we've got trolls now that Charles is doing very badly and we've identified his cheap little trick. So if we could get a couple of people just to join from the audience just to tide us over so we'd have a full panel. Thanks, James. Much obliged. Just need one more, otherwise we'll have continual trolling and silence from the panel. Dank, thank you very much for joining.
Every day.
Super, we can continue.
Would you say this is a boat that's looming, seeing as we can see the sky underneath it? Has it been
So-
loomed up?
Well, no, it appears that there's a mirage effect. It's very difficult to tell where the actual horizon is. So I'm not going to name that as looming. Like I said, there's many types of refraction, and you clearly see refraction in this image, whatever type it is.
So what is the refraction type that is bending it around the bulge that we don't see in this picture?
Well, the thing is, I don't have any.
Non-standard.
Let him answer
I don't
Arwen.
have any information about the actual distance to this ship.
7 miles.
to
7
the-
miles,
well-
2 feet height observation above sea level.
All right, so there's lots of things that are going on. All right, the thing is, refraction is a thing, and the thing that I'm amazed by for the folks on the flat Earth side is that
Where's the
if
orange
it
line?
turns out that you need to bend light 1/10 of a degree.
Oh,
to
sorry,
see-
we are now bending light then, Charles. We're bending it around the sphere of the Earth then. So we are doing precisely what I said when I asked you what type of refraction it was. We're now bending light around a curved Earth, correct?
Hang on, we're jumping the gun.
If this is from 7 miles with a 2-foot observer height, yes, like
It
I
wasn't
said,
2 foot.
if-
Listen, we're jumping the gun. Even if refraction is a thing, or nobody denies that refraction is a thing, it's still subject to showing that there's a curve for the refraction to be applied to. So
not
we'll say
necessarily.
that, sure, you can have anything you want. Show us the curve.
Yeah, no, that's a precondition. That's
No,
that's
it's a precondition of Earth as a sphere, Charles. What you're here to argue for. So don't tell us it's a precondition. Just show us the curvature. Where's the bulge?
Where's the orange line?
It's not
can't
it's not
see it,
our
so we have to
precondition.
do the
It's a
math.
precondition of living on a sphere.
Charles just answered your orange line thing when he said that you couldn't even see where the horizon was.
yeah.
Because
It's just
what's-
it's not clear.
It's not clear. It's all blended into a mirage.
I don't understand how that's the
You
case.
don't-
I don't understand how that's even possible, right? The thing that is obscuring our view isn't very clear, isn't it an obstruction in the near foreground? That's why we keep asking where it is. Apparently, this thing that obstructs our view, solid earth in our way, isn't very clear. That doesn't make a lot of sense. It's supposed to be obstructing stuff. And yet what we have is mirages that seem very similar to what you would get with a reduced viewing angle on a flat plane. But you're saying it's actually bending around the curve of the earth, right, Charles?
Well, what I'm going to point out is that in this image, which clearly has mirage effects, so clearly refraction is in play, there are many other videos where there are no mirage effects, where you have a razor.
That's not what we're looking at. So we're looking at this video, and we see something that should have a bulge in the way. And according to you, we have an inferior mirage, which is also bending around the curve of the earth with a different type of refraction, which we're not seeing when we've established we're not seeing.
I never called it that, and I never said that there is no refraction that goes around the curve.
Well, I think Charles just went for the still.
We already established this, Charles. First, you must show the curve.
Well, no, the thing is, this image really is inconclusive because of all the mirage effects, right?
Oh, really? You're going to go to that Weasley of a defense? Even though we see mirage effects on almost every single long-distance picture, you're going to say that this is a void picture? That's a bit of a cop-out, Charles.
No, there are thousands of images where you have a razor-sharp horizon, right? A razor-sharp horizon. And then, well, you know, it would be a lot easier to talk about those because then there isn't all this blurriness at the horizon.
Let me stop you real quick, Charles.
I'll show you a razor sharp.
Go ahead, Randy. But in the meantime, okay, Charles. But the issue is still the same. The ultimate issue is the ship has been brought back into our line of sight. Now, that's the issue. It actually doesn't matter about the refraction that happens in front of the ship. So when we were watching the Stella liner go behind that smaller ship, and we see this. We see this issue of refraction. That issue of refraction has nothing to do with the fact that the ship has been brought back into our line of sight. That's the issue. So it doesn't really matter if there's a sharper image, because even if Randy shows us a sharper image, that ship still had to be brought back. That's the issue.
Charles wanted to go on to different pictures though, Travis. So we've now got another one of the thousands of pictures that get taken. Randy, if you can zoom in a couple of notches, and we'll have a look at this picture, which has got a very nice sharp horizon.
Okay, so this was from 1 foot, distance 18 miles away to these buildings. And you want sharp? How's this for sharp? All of these buildings should be gone beyond the curvature of the earth.
Renty, I've already concluded to you that all of those buildings should be visible as they are in this image.
Good, because I'm going to do a £500.
18 miles at 1 foot height?
Hang on a minute.
18.
Yeah, 18.
That are buildings that are 50 feet high, 50 feet in elevation.
Let's call the boss out on that. He claims that he's already shown Ranty how all of these buildings should appear in view. So can you run this by us? Because normally should be.
Because none of your other bowler friends can do this. In fact, even
18 miles, 1 foot elevation should be, from what I remember, around 100 feet hidden. Okay, so those buildings are 50
don't just make that assumption. Whoa.
Well, I've already. Okay, I think it's around.
Distance in miles, 18 from a 1 foot observation. The hidden is 187 feet. I think you're a bit of a way out there, my friend.
Anyway, now that straw man red herring bullshit's out of the way, can you just go back to the original picture that you had up of Barrow and Finesse, and we'll ask Charles where the bulge is in this picture, see if we can establish any bulge in this one, as we've got a nice new image. Can you just go back to it, please, Ranty?
Okay, sorry. So, yeah, all of these buildings should be gone. We've already done the curve calcs on this. We're seeing down sand dunes.
Shut up, the boss. Shut your mouth, right? You've just humiliated yourself, now shut up.
Oh my.
We're looking for the hump here. Now, this is the low-lying land. This is the low-lying land over in Barrow. It's only around about 30 foot high, and the distance to that is about 15 miles away. So that's over in this corner. But all these buildings should be gone. Now, this is from the same location, give or take, half a mile. We have a very nice rock here that I've filmed in and took images from many different locations. It's actually... in the water. Just a very big rock. And that's why it shows up in front of this building. So we are seeing shore to shore. So there's a nice shore to shore. And we actually
Those buildings are 50 feet in elevation. The
Really?
base of the building is 50 feet in elevation. Yes. I have concluded that. The bottoms of those buildings are 50 feet in elevation.
Okay. Let's
Not
see
not the base of the building to the top.
No,
I meant
it's
sea
fine,
level
it's
to the bottom of the building.
Yeah, this is the Devonshire Dock Hall. Yeah, this is the Devonshire Dock Hall that we're looking at.
Ranty, he means the height above water before the building starts is 50
Yeah.
feet.
Well, this is an image of the Devonshire Dock Hall, BAE Systems, Devonshire Dock Hall, the big buildings that we're looking at, and this is them. This is the building.
That's not one of the buildings that is in the image. That is actually
Yes, it is.
behind the buildings that are
This is
in
the
front.
Devonshire Dock Hall.
I've looked up all these images.
don't
I've
look it.
identified every single
This
building
is the
in
Devonshire
that.
Dock Hall. Do you want me to show you what the Devonshire Dock...
Ranty, show him where that picture is. That
Here we
building
go.
picture.
There's the Devonshire Dock Hall. Can you see these little... Can you see the design of it? The ups and the downs and the ups and the downs. Do you want me to show you on the image?
Okay, but look at how high that is on the ground. Look at all that land there.
The actual lack of ability for you guys to do some research. Seriously.
I've done the research. I have done the research.
These are the Devonshire Dock Halls here. These are the Devonshire Dock Halls here.
Where are those little bumps on this roof?
Oh, that's the road that's next to it. There's a road on this side of it, and it's not very small, probably around about 70-foot high buildings. With
those are houses.
Houses, yes, houses. There's the Devonshire Dock Hall behind.
If you look at the cliff on the left.
Yeah, there's a refraction zone going up.
Right. I was going to say there is a refraction zone. Okay.
We've gone underneath the refraction zone here. What we've done is we've gone underneath it. I've got a series of images which I can show you. If I scan through.
That part to the far left.
Before you do, Ranty, just stick to
where the mountain stops. That's 300 feet in elevation.
Hang on. 1 second, one at a time. Sorry, what did you say, Nathan?
Well, I want to know where the bulge is. Like always. Where's the bulge?
Oh, do you want me to show you
the buildings are too high for you to even see it. They should not be obscured, as I have showed.
Sorry, is it a 1 foot elevation at 18 miles? You think there's no bulge? You think there's no obstruction?
Pretty flat to me.
Hold on, I want to get sorry, boss, are you saying...
Well, then how come you can't see the land that is below it?
Don't ask me a question. Are you
can
saying...
only see...
Don't ask me a question. Answer my question. Are you asserting that there is no bulge between us and targets at 18, 17 miles?
That is not 50 feet of land. That is a
You're
mound
not answering me.
that is 10 miles away.
You're not answering me. You're making random assertions. Calm down and try and listen. Are you asserting there is no bulge between us and these targets? Yes or no?
That is correct. That is
correct.
Sorry,
there is a bulge between us and these targets
there is
if you live on a sphere.
A bulge between you and them. Well, actually, there is, but it's not obstructing the buildings.
So, there is a bulge in your model, but there is not a bulge in this photograph, correct?
Oh my... It's not even that long of a distance.
The boss, listen to what you just said. There isn't a bulge, but there is. That's what you just said.
I did not mean to say that, okay?
Yeah, we know what you didn't mean to say, so we'll ask you for clarity if you can shut your mouth long enough and actually listen. So, is there a bulge in this picture? Yes or no?
Yes.
Where is
it? It is not obstructing the buildings.
You can't have a bulge that is an obstruction, not obstructing things. That's not how
because it's obstructing the 50 feet of land that is below the buildings.
Shut your mouth. You can't.
I just answered your question.
You can't have a wall that doesn't obstruct things if you're below it. That's not how obstructions work. If it's an obstruction, it obscures things. Yet we have no obstruction. So are you going to assert again that it's a bulge we can't see? Because we would just assert it isn't there.
Well, maybe
we can see the lower part of the land. The boss.
That's actually a mound of land.
Yeah, that's what I was.
That is a mound of land that is 13 miles away. That is where the lighthouse is.
Would you like to see what it looks like from a higher elevation and see that same mound? that's in front. See that mound?
As you can see more land. Yes, you can see more of the land.
That's just sand.
You just have a wider field of view.
This is the sand dune. We're looking down into it. I'm an elevation of about 60 feet looking down into this now. So I'm looking across from not far, not, you know, maybe 2 miles further up the coast. But essentially, these are the buildings that we're looking at. There's a Devonshire Dock Hall behind. There's the jaggedy buildings. And right in front, we have the sand dune here that we're seeing in that other image that I just showed you. Right? And do you want to see the rock? I'm going to show you the rock now. Where are we?
Because this picture is taken from a higher elevation, you have a wider field of view.
There's the big rock in the water in front of this building, but just because we're at a slightly different angle, we've got a different parallax. But this rock that we're seeing in the images is on the waterline, and it appears in front of this building from the location that I took the image from. Right?
Okay, so now go back.
If you can explain,
that mound of land is on the same mound of land that the lighthouse is on. The lighthouse is 13 miles
13
away.
miles away, yeah?
13 miles, yes.
13 miles away.
That mound of land to the
How
left
far is
is
this?
on the same part of land.
How far is this building away?
I did not measure.
18 miles. How far is that? And that's 18 miles as well. I'm just giving you all the answers here. But essentially, should be gone. Should be gone. This building, do you know what the height of this building is?
Actually, the land elevation of that, I'm pretty sure, is a lot larger than,
all right, well,
a lot higher than.
You see this building? You see this building here? You'd say that's probably half the height of this building here.
I can't tell. I can't tell. I mean,
can you not just have
angular resolution? Angular resolution, yes, it's half.
Right. Okay. You know, you would say it looks like a bit of an R. You know, because it's got this building in front of it that's obscuring it. So you can see the left-hand side of it, and then it's cut off, and you've got a bigger portion here. Would you agree? These buildings in front are making it look like an R.
Blurry. It's kind of hard to tell.
So if I show you this building all the way down the side, with it being obscured with these buildings in front, how low are we getting there now? How low would you say this part is here?
That is ground level.
That's ground level. Perfect. Right. So if I show you the
I can't tell because the image is blurry. So let's.
Oh, are they blurry? They're blurry now, are they?
Yeah. A minute ago, you knew all about this, the boss. Now it's a bit blurry. Yeah. What figures?
Well, I didn't look at those buildings when I.
Okay. Well, let me show you this building. So there's the rock in front. There's the same building. In this location, obviously the camera hasn't picked it up, but that's where the blockage would be. But it looks like an R again, doesn't it?
Yeah.
Yeah. So, like you said, this part here is ground level. Thank you very much. Appreciate your help on that. So, floor to floor, 18 miles. Charles, what do you think?
Is that building on the coastline?
Why are you're grasping at straws? Every time we present you with something, you go for something else because you have to have a bulge.
So thank you, Travis. Where's the bulge? Where's the bulge, guys?
They keep taking these buildings as if they're on sea level, but they're not.
Sorry, you're avoiding our question. There should be a
That is the answer to the question.
No, it's not. There's a 50-foot wall missing. Where's the 50-foot wall that's about 2 miles away in this 18-mile observation? Much closer and in the near foreground, obscuring our view of everything. Where's the 50-foot bulge?
As I have already explained, there's 50 feet of land under most of those buildings.
Sorry, that would be an absolute size, though, wouldn't it, Clever Dick?
Yeah, that is an absolute size.
Right, so the absolute size might be 50 feet obscured. Unfortunately, the 50-foot bulge is in the near foreground. Do you understand perspective, son?
Not in the near foreground. It is not.
So you don't think the bulge, the obstruction, the thing causing the obstruction is in the near foreground? You don't think that's the case?
It is in front of. It is in front.
1.22 miles away.
1.22 miles. According to you, it's the same height as the bulge. So at 1.22 miles, according to your bullshit ball, now you can't shut up. See, you can't help yourself. The tenacity of youth. Yeah, beautiful thing to behold. Nevertheless, there is a bulge. It is a 50-foot wall, and it is obscuring things in your model. Where the hell is it in the picture, boss? Yeah? Because we don't see a bulge. We just see something that you claim should be there, but isn't.
Nathan, listen, we have a real discrepancy over where the horizon bulge is. He thinks that the horizon bulge is there, and we're showing that it isn't there. So we need to address with him exactly where this bulge actually is.
That's my question. Where's the bulge?
That's we already addressed this. The boss. Is the horizon the bulge?
The horizon is not the peak of the bulge.
So the bulge is above it. I love it. So earlier you said it wasn't above it. Now it is above it.
You can see, but that's not how the measurement is done. Drawing a straight line from you and the distance, halfway between that distance, draw a straight line, perpendicular line up. That is the distance to land. The horizon is not that peak.
Yeah, it is. Okay?
Do you realize how embarrassing?
So you can see things beyond the bulge. It's visible over the bulge, above the bulge.
That's what you don't understand is that because
the bulge is not really getting in the way. It's just
he doesn't understand what an obstruction is.
But the horizon
see things
is
over
the most that you can see. You guys do not understand that. That's not how it works.
We don't understand how it works. Yeah, we understand how your model is failing. There should be a
the measurement to the bulge.
Don't stop interrupting. Just calm down. This is not a talk fest. You will listen as we educate you. There is a wall in the way in your model. However, we don't see a wall in the way. There's no 50-foot wall in the near foreground blocking our view.
Then where's all the land under the buildings?
Yeah, that would be an absolute size value. We've told you this several times. We are already along this little road of smashing to pieces your side elevation assertions of absolute sizes that are blocked. Yeah, we've got a 50-foot wall, and yeah, you can claim that 50 foot's missing off the bottom, but that 50 foot's in the near foreground, and we do observe perspective, the boss.
Those buildings are sitting on land. It appears that they are sitting on the water.
You realise in the foreground you have... Sorry.
Hold on just real quick. In my mind, the answer is when we see a ship in the distance looking like it's floating on air, and you're going to say, where's the bottom of the ship? It can't be floating on air. That's the same thing here. The land is that blue line. That's where the land is. Just like the ship bottom is where the refraction is happening above the water line. You can't see the bottom of the ship, but it's there. We can't see the land, but it's there because
it's being obstructed.
No, we do see the land.
In the compact zone, it is being obstructed slightly by things directly in front of it,
such as
size,
the curvature of the Earth.
Line of sight things.
Okay, wait.
Compressed eventually beyond the slant, outside of the field of view. There is some slight obstruction, but it's not the bulge. The bulge should be right in between, halfway the observer and the seen object.
But you don't understand simple geometry.
Yeah, simple geometry. The bulge should be right halfway the observer.
But if you're looking
the object
down
observed
on a circle, if you're on
that's
sphere
how a
and you're
bulge
looking
works.
down,
that's how the curve works.
Can we go back to what
halfway
that
the
is not
observer
how it works.
And the observed object.
That is not. You are making fools of yourself. That is not how it works. The bulge is the center. The horizon is not the center.
Who cares? There's a 50-foot wall between us and the target.
The bulge, the measurement that is called the bulge, however tall it is, that is the center. The horizon is not the center. It is before it.
So
Randy,
which is what I have showed you with my paper.
Yeah, sure.
Because what the boss
I already threw out my paper.
What the boss just said was that light blue line is the bulge. So now he's given us the bulge. We can see it. That blue line,
right. Well, hang on.
See
if that's
how those
the case,
buildings appear to be sitting on the water. Okay. See that?
Yeah, but no, boss. Let me.
No, they're not. They don't appear to be sitting on the water. They appear to be sitting on land.
Hold on.
Of course they are. There's the land in front. There's that hump. There's that sand dune that's in front of that building that I was pointing out.
That's 13 miles away. That's not the same distance as buildings.
It's just spouting.
Yeah, but that's not the
says it's 13 miles. You shouldn't see that.
Let me try to just bring it back. The boss either needs to retract or confirm. That blue line above the dark blue water is the bulge. That's what you said. You said that blue line when I was describing my situation. You said that's the bulge.
It's a pretty flat bulge. As you can see the beach on the other side.
Is there anybody interested in adding perspective to this discussion?
No, because I want to
Already in the
stay here
picture.
with the boss and try to at least address what he said. Because when I was describing,
When did I say that that blue line was bulged?
You can go back a couple of minutes from
no
now.
problem. No problem, Travis. Rather than getting him to go back and backtrack, where is the bulge then, the boss? My question, 50th time.
If you just look at a picture of another building, you can
We're looking
see...
at a picture right now, and we've asked you dozens of times to identify the bulge, and you just yatter and 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 won't shut your mouth.
It's a ground level. You just confirm.
Yeah, and the ground is the ground level is different from sea level. You were aware,
Is that
of, right? That ground is
187 feet obscured. It should be.
Excluding perspective. Absolute sizes.
Nathan, I'd just like you to know that that statement was completely irrelevant because you do not need to account for perspective and angular resolution when considering these. All you need is the absolute values, and that is all that matters.
That's total horseshit. We don't see anything in absolute values. That is a concept. We don't see absolute sizes of anything, you utter idiot.
I'm done
Don't
with this
sigh.
shit.
Don't tell me about how I see a concept.
I'm not the one that sighed. That was Ranty.
That was me. I'm kind of done with this kid. He's like...
He's just an idiot.
He must be from a special school.
Yeah, total idiot. We don't see in absolute sizes, idiot.
And
you've just asserted that we do.
if you see an object that's...
Oh, so you're going to ask me something, are you, retard? We don't see in absolute sizes. That's a concept. It's not how we see things. We see in perspective. We do have to account for it, you idiot.
Okay,
Well, then how do you account for it?
The boss, hold on. The fact that you're bringing up, and you just said what the standard response is. We've been harping on this for weeks and weeks and weeks, and yet you come back and you say the exact base response for someone who has not thought through reality.
Sorry, what was that? My headphones fell out.
I'm not repeating myself.
Okay.
Forget it.
Anyway, Sly Sparkane, shall we address his little malfunction on his program that he said was...
Oh, yeah, I can explain that perfectly for you.
Go on.
Shut up,
drag
the
the
boss. Shut your mouth or I will kick you out. Keep your mouth shut.
He dragged the object too far away for it to render, for the 3D modeling software to render it. That's
Shut
all
up.
That happened.
Shut up. We haven't brought this up for you to discuss.
Ranty, I saw your 16-second video. That's all
Okay.
there is to be said.
That was literally just an outtake of what he did live. So have you used 3ds Max?
I've muted him because he couldn't shut up.
The video that I saw from Slice Arcane, what was demonstrated on this show, that part pretty much showed how angular size can be calculated in orthographic view on a flat plane.
So he does Blender 3D, but he doesn't use 3ds Max. Well, you see, the thing is, I did a degree, and I had a degree in media, and part of that was using software such as 3ds Max and the entire Adobe suite. So when somebody says to me and tries to blag that the rendering malfunctioned on the 3ds Max, I call horse manure because I've worked with that program. I did a degree in it, and I know for a fact that that was not a glitch. Wrecked again. Lying. It went due to perspective.
Well, no. His point is still valid. So I've got to disagree with you there, Auntie, although we've had this conversation earlier. It can't disappear just because of perspective. You have to have something intersecting the midpoint. So in my demonstration, I'm using my car in the foreground as the bulge, as we've done before and since, because we're trying to destroy their model based on a near foreground obstruction, i.e. the bulge, which is bigger by virtue of perspective. So when Sly takes my model, he says, right, we've got to look over the top of the middle car. Now, if we're completely tangent to it, or 90 degrees to the top of the car, the thing in the background will only be obscured by the amount that it was obscured originally, and you could slide it indefinitely if you had indefinite zoom. Obviously, there's not going to be any of these optical effects that we're detailing in this show, which is the thing that will eventually obscure it from bottom up. But in that respect, his point is correct. If it wasn't correct, you wouldn't get the images that you get on a calm day when there's nothing obscuring the midpoint, i.e. the point of convergence. So because you've got calm waters, you can see for a very long distance, like Sly's demonstrating. So in that respect, Sly's demonstration is excellent. Yes, he backs up what we're saying. You can see for a very long way because we're on a flat plane and things aren't getting it.
You're not going to see a fly at 150 miles away.
No.
That's ridiculous.
Well, no, of course not.
But in their opinion, that's possible.
Well, no, but what you could say, though, is at 150 miles away, if you had infinite zoom, then potentially you could bring it back if it was above the point of convergence. But we're saying that that's fine in 3D rendering. In the real world, we have effects at the horizon, the circle of confusion, the point where things start to stretch or become squashed or have refraction, which is Charles' definition of a mirage. All of these effects happen at the horizon, at distance, when you have a very, very narrow viewing angle. But the viewing angle alone, if you are completely adjacent, which is the very narrow point that Sly's trying to make, is true. You can slide it back indefinitely, so long as nothing obscures the midpoint.
Do you remember that we did that LK video? And we analysed it. And we were saying there was compression at the bottom.
Ailsa Craig?
The Ailsa Craig, yeah.
Yes, yes, yes.
So how do you think today's presentation works on that scale?
Who are you asking?
You.
How do I think that works in terms of what gets obscured?
Yes, and how it works with what we saw with the Ailsa Craig, which was the entirety of the mountain, but compressed at the bottom.
Well, exactly what you've just described. We get the top half of the mountain because it's above that very narrow angle of incidence that you have when you're at ground level, but the stuff that's close to the bottom of the mountain is compressed, it's squashed closer to the horizon. There will also be a certain amount of weather in respect to the waves splashing above the midpoint, which will also cause a slight obstruction. So those effects combined gives you the view that we saw.
Yeah, I mean, I can present that image if you like, because I'd like to redress it, because I know and I'm confident in my analysis of that we saw everything of the Ailsa Craig. Let me know when I'm showing, Dave.
You are.
Yep. So we already been through all this. We've already measured up the points and where the points match up. The only difference was we noticed that these ledges here, which were down here, and this drop-off point over here, this is from the really far distance, by the way, this one. They were compressed, clearly compressed.
You guys are aware that his video perfectly matches up with the curve calculator, correct? How do you explain that?
The compression
because it doesn't omit
bear with me a second.
Perspective.
So, the boss, I'll just say this again because it's obviously just not sinking in. The curve calculator deals in absolute sizes, whereas you have a
and that's all that matters.
You're going to just interrupt me. It does matter.
Well, because you're wrong.
No.
It does not matter. How many times do we have to explain this to you? Angular size does not matter in a curve calculator.
It doesn't matter in the curve calculator, but it matters in the real world, and we are comparing to the real world. Therefore, your calculations do not work because they only work with absolute sizes. And as I said earlier, absolute size is a concept which our eyes do not deal with. We only deal in angular size.
Okay, I have an issue with the picture, Renty.
Sorry, well, you haven't just conceded. You do this every time you want to make a question. Do you understand that we don't deal with the world that your calculator presents? Yes or no?
That is the real world. That is...
No, that's a calculator. You absolute buffoon. Not only is it just a calculator, it's an orthographic calculator that only deals with the world in absolute sizes.
It perfectly represents the real world.
In your imagination, the boss.
It excludes perspective. For the love of God, this is getting tedious.
Okay, so, Ranty, the image you have on screen...
No, We've already moved past the point of getting others smarter and older and more mature than you to concede that your calculator excludes perspective. We've even had people come on to assert that they've made a new one to fix the problem. Now you're asserting that your orthographic calculation is representative of the world. It is not.
It does exclude perspective. No one's denying that. But what does...
Right. We deal with a perspective-based world, son. Okay, Sunshine? Sunny Jim? We don't deal with an absolute size world, we deal with a perspective world. So shut up about your calculator that's broken, begging the question, perspective omitting, and proof of nothing.
How can it be broken if
shut up.
Everything lines
Shut
up with it?
Up.
We can add compression omission now, because this is what we are seeing. Compression omissions.
Okay, on the bottom image, you have the wrong thing on the right. That is not what was on the right box on the
where's this massive ledge that drops completely almost vertically? Where would I find it above that? Where
actually you have the wrong thing box on the bottom. The thing on the right does not match on the top. That is
his
not
question. He asked you, where is it above that then? So if you're to assert that it's being cut off by a bulge that you won't identify, where does it match on the top one?
The top one is the further away image. Okay.
Yeah, you don't need to assert some random shite about what the image is. Answer his question.
I'm asking where this drop off on here.
See the top left corner.
You can't even shut up long enough for him to re-ask the question that you didn't understand when you started asserting random nonsense about the picture that we don't need to know. Listen to his question, shut your mouth, and just listen to his question be repeated so you can understand it. If you don't shut up, I'll start getting you to repeat the question and really humiliating you.
I'm talking to Ranty, not you.
Right.
Yeah, well, if you don't talk to me, you get ejected because I'm the host.
You see this ledge here that's clearly this ledge here, and then you got the drop-off point, and you got, what, because Simon Dan did it? Are you retarded? Do you want me to show you what Simon Dan's been up to? Buying fake subs, that's what he's been up to.
Let's not go on to ad homs about Simon, the pathetic weasel that's buying fake subs, Dan. Let's just stick to where the sledge is in the above image if you're to claim that the bottom half is being...
claiming that this drop...
It's obvious that he's correct.
is here. Is it obvious?
Let me ask a question just real quick. The boss. Are you willing to acknowledge that both of those images are the same geographical landmass?
Yeah, that's the same landmass, but however, they are taken from slightly different angles, so there will be some differences.
Sorry, you're now using the angular size. Can't we just use the absolute size? You don't count for angles in your real-world calculator that represents the world, you dumbass. Why are you now telling us about the angle of incidence? This is our point. Don't try and use our point. Your calculator doesn't deal with angles.
You just completely twisted my words.
You don't deal with angles in your calculator. Don't try and assert the angle of incidence as a defense. That's our point.
Right, Nathan, can we just say that this is saying
not
that
angular size. You took it from a different location.
Yeah, try to listen. You don't shut up long enough to listen to the words angle of incident, not angular size, dumbass.
You just said angular size.
Right, angle Nathan, of incident, the height, the angle that you attack the target. All ignored in your very real world, not representative of anything, begging the question, proof of nothing, perspective omitting, calculator.
I'm saying that he took it from a different location, so it's slightly rotated.
Oh, really? Well, it would be handy if your calculator applied angles to things. It doesn't.
It only shows how much in a certain unit.
Again, yet another zero acknowledgement of his retarded point which we've just demolished. You are the most annoying kid ever. You don't concede. Been well trained by the Globeheads to never concede anything and just move on and ask a new question.
Well, can I concede?
Might be age related though.
Nathan, he's saying.
But I'm sorry. This is just my entertainment.
This little ledge here is this massive ledge here. That's what he's saying. This little drop off here, right? So this little drop off is this entire side of the mountain. That's what he's saying. Am I right? That little drop off there is all this.
No, I'm saying that what you have boxed on the top. No, the thing that you have boxed on the top.
This one, yeah,
is not what's boxed on the bottom. So if you want to take what's
you said was here.
No.
So tell us
So
where
is
it
this
is.
box in the same place?
Where is it then?
No.
Not no. No is not an answer. The original question was where is it on the top image then? You just couldn't shut up long enough to listen to the question.
I answered it, but whatever.
So where is it? Point his mouse to it.
See, he's just here for the entertainment. He's just said us that. We're here for the research. We want proper
we're here for
ballers
the
to come
truth.
in.
You ballheads are just here for the entertainment. What bunch of wankers.
I'm not. Oh,
You're a
I'm
little
not here to
wanker.
troll. I'm actually using actual.
You are a little
science
wanker
and
just here for the entertainment. We're here for the truth of what our world is. You're here for the entertainment because you're a wanker.
We do the work.
Come on,
we
you
do
can't
the
blame him
research,
for being a
put effort
wanker. He's
into
only
it.
15. Come on.
Well, I'm
You're
sorry,
people,
but
you know?
he needs to be kicked now.
No, you can stay here. I don't mind him being here.
This is entertaining. That's
He
all.
doesn't
I
swear.
mean, I'm trying to be serious, but this is just too entertaining.
You're
That's
trying to
why I
be
come
serious,
back.
but
Yeah,
you're
you're being
so
serious, but you don't
indoctrinated.
believe in actual observation. You don't believe in perspective. You believe in your model, and you can't get it through your head that that's not how observations work.
You're
Yet
indoctrinated.
you keep stuck on that broken record point of yours. It's ridiculous.
And with that, I'll say a first and foremost huge, massive, enormous thank you to all of the live panel. Hello, Monster. You're going to come and say hello for the outro rather. A huge, massive, enormous thank you to all of the live panel for making this debate possible. And of course, a massive thank you to all of the live audience for tuning in and hopefully sharing this debate. If you hated the show, you know exactly what to do. But if you liked it, consider sharing it with a friend or subscribing if you have not done so already. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!